So we are in section 1 of chapter 4 of your chemistry, and we're going to go through some of these balancing equations. So here are your questions here. The concept review is pretty easy questions. It says define a chemical reaction, and that's chemicals that are reacting together to form different compounds or different chemicals. So what group of substances on the right side of the arrow? On the right side of the arrow, we have what? The products. On the left side, we have the reactants. So the reactants are on the left side. Those are the ones that are reacting with each other, and the products are on the right side. And that's of our balanced equation. And then it says, state the law of the conservation of mass. Basically, mass cannot be created or destroyed, and neither can atoms. So the atoms are being rearranged in a chemical reaction. So now I'm going to go through just the first three of those A, B, C, and just show you how to do these in case you're going to have these on the test. And then basically they give, these questions, they give you the formulas and you just have to balance them. And then this number 2, you're going to have to do the formulas too. So we'll do a couple of those and then we'll go on and to the section 4. But you need to have to know how to do these on the test. And they're actually kind of fun. They're kind of like a puzzle. And sometimes if you make a mistake, just start over. If you make a mistake, and usually the mistake comes in with the formulas in themselves. And sometimes you just, you've counted a subscript wrong, or you didn't catch, a coefficient in front of it or something. So you'll find out. But anyway, like I said, it's kind of like a puzzle. And remember, because they have to balance on both sides, because you cannot destroy atoms or get rid of them, right? Or they turn into or energy or mass, and atoms or mass. So here we have our review. So this is what they give us. They gave us aluminum, which is a solid. Remember, you have to write these little things in parentheses that tells you what they are. And then you have oxygen, which is a gas. This is a pretty easy one. So you have aluminum combining with oxygen. And this whole thing, this is what happens, oxidation. It's actually producing aluminum oxide here, okay? And so here's what they give you. We have to balance it out because it's not balanced. So we look here. So first of all, we look, I always take the one, start here with the one that has the greatest or the more complicated of the molecules right here. So I took this one here. I look and start here. I look at aluminum. So we go over and I look at oxygen. So right here I go over to aluminum and I look. So I know right away there's 2 aluminums here. So I need to put 2 aluminums on this side. So I put it in front as the coefficient. So I put a 2 before the aluminum. So then I look at the oxygen here and I see there's 3 oxygens here and there's only 2 oxygens on this side. So that's kind of a problem. So 3 and 2. So we're going to have to basically, if I put down 3 divided by 2, so I put 3 halves with 2. So 3 halves with 2 would be 3, right? But we don't really want to deal in half of oxygen molecules, right? So what I do next is I'm going to take this whole equation and I'm going to multiply the whole thing by 2. So that's what I did here. So I multiply here, aluminum is 2 here, so I multiply this by 2 and I get 4. I multiply 3 halves and I get 3. And I multiply this is a whole molecule in itself, so I multiply this whole thing by 2. So now I have to look and see if it really balances out. Well, we have 4 aluminums, and since I multiplied this halves, I have 3 oxygen. So I have 4 aluminums on this side. Oh, I have 4 aluminums. 2 times 2 is 4 on this side. That's fine. Checks out. Now the oxygen on this side, I have 2 times 3 is 6. And I look over here. I have 3 times 2, because there's the coefficient in front. 3 times 2 is 6. Now, this just means it's a solid, and this is a gas, and this is a solid. Okay? Alrighty, let's go on to B here. Find out they are not really that hard. Let me back up here so you can see the whole equation. There we go. Okay, so now we have hydrogen sulfate and lithium hydroxide, and they combine to form lithium sulfate and water. Okay, So now we know this happens. You're given all this. And so make sure you put down the aqueous, these little aqueous, and liquid. So you make sure that all these little in parentheses tell you what we're dealing with. So now we have, we start here. I started here with the hydrogen sulfate. So I look at the hydrogen. There's two, well, actually, I started here with the lithium. Probably start with the lithium here. Either way you can start because they're both pretty complicated. But here I started with the lithium. So I look at the lithium. And there's 2 lithium, so I go over to the side. There's only 1 lithium, so we're going to have to put a 2 here. So right away, I put a 2 lithium in front of the lithium, right? So now I started here, I put the lithium here, and came down here, the next one. And so now I have to look. The weird thing about this equation is that there's hydrogen. Here's hydroxide, but there's also hydrogen up over here. So we have to make sure the hydrogen atoms on this side equal the hydrogen atoms on this side. So I add them up. There's how many? There's H times 2 is 2. So there's 2 hydrogen here, and there's 2 hydrogen there. 2 plus 2 is 4. So I have 4 hydrogen on this side. So I'm going to need 4 hydrogen on this side. So I look over here and I see I only have 2 hydrogen. So I'm going to have to put a 2. See what that 2 is? I'm going to have to put the 2, which I put the 2 there. So I recopy the whole thing. So I have H2SO4 here and plus lithium and hydroxide here. I just copy these down, and I put 2 waters here. So let's move this up so we can see it better. So now I want to look to see if they balance out. So of course we looked at here. We have how many? We have 2 hydrogens here, 2 hydrogens here. We have 2 times 2. We have 4 hydrogens here. So 4 over on this side and 4 on this side. So that's okay. How about the sulfate? There's only 1 sulfate on this side, and there's 1 sulfate on this side. So that balances out. That's SO4. And now we're going to look here at the lithium. There's 2 lithiums here. There's 2 lithiums here. And the OH, basically here, we're going to look here at the O, because we looked at the H already. Well, there's going to be 2 oxygens here. And of course, we have 2 oxygens here. This balances out. Alrighty, see if we get the next one. Okay, here's our next one. Keeps falling down, sorry. Alrighty. So here we have, we're going to start. Here we have, they've given us ammonium, oxygen, and you heat it up. This delta sign means just that we have to heat it up for the reaction. And it produces nitrogen and water. So basically, as we look here, this is going to give us, ammonium is going to give us nitrogen and water, but we have to balance it out. So now we start here with this one because, of course, the ammonium molecule looks like it's definitely more complicated than all these others. So we start there. And so we look over here and we look at the hydrogen. Oh, first of all, we look at the nitrogen. So we're looking at the nitrogen. And so we look at the nitrogen and there's 2 nitrogens here because nitrogen is diatomic. It only comes in 2s when it's by itself. So now we're going to have to put over here. There's only 1 nitrogen here, so we had to put a 2 here. So now that we put a 2 here, we're going to make this hydrogen. It's going to be 3 times 2 with the coefficient, 6 hydrogen. So we looked over at the hydrogen here. And hydrogen only has 2 hydrogens, so we're going to have to times this by 3. So I put a little 3 there because I'm going to have to add a 3 to make this 6 because there's 6 hydrogen over on this side. And so that's what I do. Let's move this up so you can see it better. So, So basically here, where was I with the, okay, with this, so I move this down here. So I have 3 water, which is H2O. And I'm going to have 1 nitrogen. On this side, I have the oxygen, and then I have the ammonia. Well, now the oxygen, we have to deal with the oxygen. Well, on this side, again, with the oxygen, I have 3 oxygen. And on this side, I have 2 oxygen. So we have this 3 halves thing again. So basically what we're going to have to do here is change this to 3 halves. So because 3 halves times 3 halves would be 3. So it'd be 3 on this side and 3 on this side. But do we really want to deal with halves? Do we really want half of an oxygen? Not really. So we need to get rid of that half. So how are we going to get rid of that half? We're going to have to multiply the whole equation, both sides, by 2. We do this whole thing, then we're going to get rid of that half of oxygen. So what we do is 2 times 2 is 4, so we have 4 ammonium there. Then we do the 3/2 times 2, which is going to be 3 oxygen. And as we heat it up, we're going to go to 2 nitrogen. And because we have only 1 nitrogen here, so now we have 2 nitrogen. And then we have to multiply the 3 here by 2, which is 6. So we have 6 waters. So in the midst of all this, what we're gonna see is we're gonna have 4 ammonium molecules, and they react with 3 oxygens, producing 2 nitrogens atoms and 6 molecules of water. So see how that balanced out? That was kind of easy. Okay. Yeah. Let's do that. Take that out so you can see. I don't want you to get mixed up in another problem there. So here we have, now we're going to have it a little more complicated, because if you look in your book, what does part 2, number 2 says? It says write the formulas for the reactant. So we have to write the formulas and products for the balanced solutions. So we have to write them out. Okay, I wrote them out here, but let's look and see what they are. Okay, number 2 says solid iron oxide 3 has positive ions of 3, forms from its elements, and so we want it, basically this is going to be, we're going to take its elements and form iron oxide. So what's the elements going to be? Iron and oxygen. Okay, let's see how I did it. Okay, so we have solid iron, and then we have oxygen. So we have iron, which is Fe, and it has positive, it's an ion of positive 3, so it has 3 plus. And then we have oxygen, which is only 2 negatives, and it's going to form ferrous oxygen. But now we need to know what these little subscripts are going to be. Well, since we have 3 of these, 3 times 2 would be 6, right? And if we have we have, let's see, 2, there's 3 ions times 2 equals 6. So we put a little 2 there. And then we have, for the oxygen, we have 2 negatives. Well, we're going to need 3 oxygens. So we have equal. So we have ferrous, which is iron, will be 2 iron, and then we'll have 3 oxygen. This little sign here just means that it's a solid. It's a S. So kind of disregard that right there. So anyway, so now we're going to look here. So we'll look at the ferrous. There's 2 ferrous here, right? There's only 1 ferrous here. There's only 1 iron here. There's 2. Ferrous is iron. There's only 2. There's 2 here. There's only 1 here. So I'm going to look over here, and I'm going to have to put a 2 there. So that's the first thing I'm going to do. So I put 2 iron plus oxygen equal ferrous sulfate here. Well, I look over here. Now I got to look and see if the oxygen. So how many oxygens do I have here? I have 3 on this side, again, 2 on this side. So we're going to have the half thing, aren't we, again? So we have 3 on this side and 3 on this side. So we're going to have 3 halves here. So 3 halves. So I have 2 ferrous, 3 halves of oxygen onto the ferrous, basically the iron oxide here. So I said ferrous oxide, but iron oxide is better. And it's solid. So here I have there like that. So now I'm going to have to get rid of this half, because we don't want a half of oxygen. So to get rid of this half, let's push it down here so I can see it better. So to get rid of this half, we're going to times this whole thing by 2 to get rid of that 2, a half. So 2 times 2 is 4, so we're going to have 4 irons. And we're going to have how many oxygens? We're getting rid of the 3 halves times 2, so it's only going to be 3 oxygens. And then we're going to go on this side. We're going to multiply this side by 2, so we have 2 iron oxides here. So this is actually balanced. So we look, there's 4 on this side, there's 2 times 2 is 4. There's 4 on this side of iron and 4 on this side of iron. There is 3 times 2. There's 6 oxygens on this side. And this we have 3 times 2 on this side. And we have 6 on this side. So this is balanced. So basically the hard part of this was to put together these ions and put this little 2 and 3 up here to make sure we have the right formula. If we don't have the right formula, we'll really be off. Okay. The next one says, okay, when it is heated, magnesium hydroxide, let's look at, we're gonna have to look up magnesium hydroxide, solid, forms magnesium oxide, solid, and gaseous water. So let's write that out. Basically, the hard part of this is writing this out because this balances up pretty good. So magnesium hydroxide solid forms magnesium oxide solid. So we looked this up in magnesium, and we looked it up. Remember, I told you to look it up on your on your list, that you have the list of them. What did I do with my list? Well, it's in your book. Your list is in your book. I don't have it here, but it's actually in your book, and chapter 3 tells the list. What did I do with my list here? Let me look through these. Oh, here we go. Here's my list here. So what I did is I looked up, first of all, I have to look up magnesium. So magnesium is +2. Can you see that on there? Let's see. Magnesium. There's +2. Magnesium is +2. So we know that. So then we look at hydroxide is OH. Is hydroxide. So let's look at hydroxide. Hydroxide is on my list, and it's OH, a negative OH. So there's only one negative. So that's important because now we have to make this out. So I have magnesium, and I realize it has 2 pluses, 2 positives, and basically hydroxide only has 1. So I'm going to need 2 of these molecules so that these 2 will balance out, right? And so I put a little subscript 2 there. That's all I have to do. This is what we only put the subscripts when we're putting our formulas together to see what the formulas really are. And so on this side, we have to make sure magnesium oxide, this is magnesium oxide. Well, magnesium is on our list, and it has a +2, and oxygen is a -2. So this balances out with the ions. And then, of course, we have water, H2O, right? Not balanced. So now we want to look if we're balanced out, because we have magnesium oxide with a little 2 here, and we want to make sure that it balances out on the other side. So first of all, we check the magnesium. Yep, magnesium 1 on here, 1 magnesium on this side. Now we check the oxygen. So we have oxygen. On this side. There's 2 oxygens. Okay, there's 1 oxygen here, and there's 1 oxygen here. 1 + 1 is 2. So here, this is where you can make a mistake. You can think, oh, there's only 1 oxygen. No, there's oxygen with the subscript is 2 oxygens. So there's 2 oxygens there, and there's 1 + 1 oxygen, 2 oxygens here. How about the hydrogen? Hydrogen has 2 on this side. Hydrogen has 2. So this was already balanced. We didn't have to balance the whole thing out. So let's go on to number C. I think I just did number C. I didn't do the last question on here. So, but I'm not going to do them all because we're going to have to do them for the test anyway. But just so you know how to do these. So let's see where I am. Okay. So this one says aluminum metal reacts with aqueous phosphoric acid to produce hydrogen gas and a precipitate of aluminum phosphate. So here we have the aluminum metal. Aluminum metal is just Al, and it's reacting with aqueous. Make sure you put your solids and your aqueuses down here, which I didn't do in the end, which is very important to do that. So, but anyway, so I put solid, that, and then we have the aqueous phosphoric acid. So phosphoric acid, if you look, he's on your list, is H3PO4, and this is hydrogen gas is left over with aluminum phosphate. Aluminum phosphate. Phosphate's another one that's on your list to know. And you can look it up on that list. Right here is phosphate at the bottom of your list. Right there, phosphate, okay? Okay, so putting this together, you know, we looked at the aluminum has 3. We look at aluminum phosphate, they go together because phosphate has 3 and aluminum has 3, so we're pretty good at that. And then we know basically we're going to look and see the phosphate here has 3, so we need 3 hydrogens. So I had to put the 3 there for hydrogen. So I'm putting this together because you need 3 positives of hydrogen with the 3 negatives of phosphate. So that's why I had to have the hydrogen with the 3 on it. And hydrogen also always is a diatomic, so it's always when it's alone, it's always going to be with a 2. We learned that in last chapter too. And so now we have the aluminum phosphate. Aluminum is 3 positives and phosphate is 3 negatives, so this works out. So now we have this equation, so we have to make sure it balances. So we look at the equation, and as we look at the equation here, we look at take the one of the hardest ones here. So we took this here, and we look here, and we look to see, first of all, well actually we start over here with the aluminum phosphate, either one. So we look over here, the aluminum, you know, as we look over to the aluminum, we're looking over aluminum's over here, aluminum's 1 over here. How about the phosphate? The phosphate is 1 and the phosphate is 1 over here. So we can't really do that yet. So let's go on to here. So basically we look at the hydrogen. So we look at the hydrogen here. Hydrogen is 2 here and it's 3 here, right? 3 here and 2 here. So basically, as the hydrogen there, we're looking at the hydrogen, we'll have 6, 3 times 2 is 6. And look over here, 3 times 2 is 6. Well, before we even, let me start this over a little bit here. So let's look up here. So we're going to look up here. We're going to look at, we'll start over here. The aluminum, we look up the aluminum. There's aluminum over there. Look at the phosphate. Okay, there's phosphate over here. So we want to go over here. Phosphate's over here. But so this whole thing was balanced out. But now we're going to look over here at the at the hydrogen. So we have 2 hydrogen and 3 hydrogen. So what we're going to have to do is make these into 6 hydrogen. So we have hydrogen 3. So we put a 2 in front of here so we can make 6 hydrogen on this side, and we put a 3 here so we can make 6 hydrogen on this side. Okay. So now we have the hydrogens equal. But now we have to look, since we added this over here to the phosphate is going to be off. So we're going to look over here at the phosphate, and we look over, there's going to be 2 phosphates here, PO4 here on this side. And let's look over here. Over here there was only 1. So I had to add a 2 over on this to make this phosphate all legal. And since I added 2 over here, phosphates, the aluminum's not going to be equal. So then I go all over here and I'm going to add the aluminum. 2 in the aluminum to make aluminum. So now down here I have 2 aluminum plus 2 hydrogen phosphate here, which I want to look at the hydrogen. There's 8H hydrogen, there's 3 times 2, so look over here. There's 3 times 2, 3 hydrogens here, they work. And so then I look over at the phosphate here, there's 2 phosphates here, and there's 2 phosphate here. So this whole thing balances. So sometimes when I was describing it, you have to go back and kind of do a recap of it, you know, because it gets a little complicated. It's easier to do it when you're just doing it. And I'm telling you how to do it. So when you're doing it, it's actually easy to do. And if you get stumped, you just go right back and start again. So I think we're going to end right there. So there's another gaseous chlorine with aqueous sodium. So that's just another one, but basically you know how to do this. If you have to put together the formula and then you balance it out. And it's kind of, you know, using trial and error to balance it out. And sometimes it takes a while, and sometimes you have to think, how can I do this algebraically? But anyway, this is the end of chapter 4.1.